Let's dig deeper into Redux. Up to this point, we only dispatched simple actions. They only had a type, nothing else. In reality, you often want to dispatch actions that also carry an extra value. Let's say we want to add a new button to the counter component, which says increase by 5. We could, of course, also add a decrease button, but let's stick to the increase button for now. Now, even though it has this label, it of course only increases this by 1, because I still just call the increment handler here and dispatch increment. Of course, we could now go to the store and prepare our reducer for another action type, which is increase by 5, where we then return our updated state, where we increase the state counter by 5. But that's not scalable. We can't predict all possible values we might want to support. The counter, of course, is just a dummy example, but if you're using this in a real project, which we'll do later in the course, and you need to work with any user input, for example, you can't hard code those values here in your reducer. Instead, the action which we dispatch and which reaches the reducer often needs to carry extra data. So that, for example, we have an increase action type here, and that action type does not increase the counter by a fixed number, but instead we expect to get the value by which we want to increase from the action. In there, we could say that we expect to get the value property or have an amount property or whatever it is, and then we want to increase by that. That would be a reasonable expectation, and that's of course a very common scenario, hence Redux and React Redux supports it. Back in the counter, we can now add a new function here, the increase handler, and in there we again want to dispatch, but now the action which we want to dispatch will not just have a type, it will have one and the type is increase, but it can now also get an extra payload, extra data which it carries. For example, an extra amount property. And this property name is entirely up to you. It's your action, it's your action object. You can add whichever properties you want. So here I'll add an amount property and set amount to 5 here. Of course, 5 is therefore still hard-coded here in this function, but that's just a demo. Of course, this value could be coming from an input field. Here it's hard-coded, but now we can point at the increase handler here. Now we add this extra payload to the action, and in our store in the reducer function, when the type is increase, we do expect this amount field on the action. Therefore, of course, you need to make sure that the property you're accessing here on the action in the reducer has exactly the same name as the property you add to the action when you dispatch it. Otherwise, you won't be able to extract this data. Hence, now if we save this and reload this, we do increase by 5. But now this is very flexible. We can easily change this to 10, and for completeness sake, change the button text to 10 as well. And now we increase by 10. It works just like that, because now the reducer is dynamic. It extracts an action payload. And action payloads are very common, often needed, and as you see, it's super easy to add them. It's just an extra property which you add to your action objects. So now we already learned quite a bit about Redux, but up to this point we always just worked with our single counter value. Now I got this toggle counter button here, and when it's clicked, I want to make sure that the counter is hidden, and when it's clicked again, it should be shown again. Now for this, of course, we could use state. So we could set up some local state in this component, which we manage with useState, not with Redux. And that would be the proper way of doing it, because showing or hiding the counter is something which only is interesting to this component, not to any other part of the application. But the same could be said about our counter. we are only using the counter in this component here. So the counter technically also is local state. But this is just a simple demo to get started. So let's assume that both the counter as well as the state, whether the counter should be visible or not, is a global state, which is also interesting to other components, even though that's not the case here. As we progress, once we know these basics, we will of course also work on demos and projects where this then really is the case. But for the moment, let's assume it. So when we click this button, the toggle counter handler is fired, and then here we want to dispatch an action which changes some state in Redux, which controls whether this counter div is shown or not. For this, we need to add a new state, a new piece of data to our Redux store. And how do we now do that? Well, to add a new piece of data, we need to go to our reducer in the end and just add it to all these state snapshots which we are producing. Let's start with the initial state snapshot. When we start, besides having a counter which has a value of 0, I want to have a show counter field which has a value of true or false. That's up to you. And to keep this a bit more readable, I'll extract that and store that in a constant named initial state like this and assign initial state here then, just to make this a bit easier to read. Now when we increment, we are changing the counter. We don't care about show counter. We still need to set the show counter property here though, because we are returning the overall state object. And Redux won't merge your changes with the existing state. It instead takes what you return and replaces the existing state with it. More on that in a second. But for the moment, let's just accept it. And let's set show counter here to state show counter. So to the value we currently have in our state. Because for increment, we don't want to change it. So we will just take the existing show counter value. And we can do the same here for increase, because there we also want to keep the existing show counter value. And do the same for decrement here. But now I will also handle a new action type. And by the way, since we have many if statements here, we could also use a switch case statement, but I will stick to multiple if statements here for now. And in this new action type, I will check for, let's say, toggle. Now the identifier, just like all these identifiers, is up to you. I'll go with toggle and then return a new object. Here we now want to change show counter and set it to the opposite of what it was before. If it was true, we want to set it to false. If it was false, we want to set it to true. And we can do this by simply adding an exclamation mark and then accessing state show counter. This will invert the value. Now for the counter itself, we want to keep the existing state because we don't want to change this here for this action. So we just set counter to state counter. Now we also support this new toggle action type, and hence back in counter.js, in the toggle counter handler, we should dispatch such an action. We dispatch a new action object where the type is toggle. Now we can take advantage of this toggle state, so of the show counter state, and for that we need to get access to it. So also in the counter, we again call use selector. We can use this multiple times to retrieve different pieces of data from the state. And here I'm then interested in my show counter piece of data. And I'll store that in a show constant. The constant name, of course, is up to you. Now again, that will then always update and the component will be re-evaluated whenever that data, which we're accessing here, changes. So now here with show extracted, we now can render this div here conditionally by checking if show and only rendering the div if show is truthy. Like this. If we now save this and reload, if I click toggle counter, it's gone. If I click this again, it's there again. I can still increase it even if it's hidden, but it only shows up when I click toggle counter. So that now also works, and that is how we can manage multiple different pieces of data in our state. Of course, this data is still kind of connected. We have the counter and then the state, whether we want to show it or not, but it's two totally different values which are changed in totally different ways. So therefore, that is how we can manage multiple pieces of data. Now let's talk about the objects which we are returning in our reducer, in our Redux reducer. I mentioned in the last lecture that we always return a brand new snapshot, a brand new state object, which Redux will use to replace its existing state with. So the objects which we return in the reducer will not, and that's super important, will not be merged with the existing state. They will overwrite the existing state. So if we, for example, don't set show counter here when we increment it, because we forgot to add it here, if we do this, if I click increment, you see I close my counter. I close my counter when I click increment, even though I shouldn't, because I don't set show counter here. Hence, it's basically removed from the object, and it has a value of undefined, therefore, and undefined is treated as falsy, so we don't render the counter then. And that's, of course, a side effect which we don't want. That's an error. So we must always set all the other states when we update a piece of state, because we overwrite the old state. Now that brings up one question. Why do we need to return a new piece of data here? Why can't we just use the state, which we're getting as an argument, access counter, and increment it like this, instead of returning? Or maybe we do it like this, and then we return state. And when we do that, we change state before we return it, and then we just return it again. Well, if we do that, and we reload, everything works. So it's not easy to see that this is wrong, but it is, even though it works. This is something you absolutely must not do when working with Redux. You should never, super important, never mutate the state, the existing state. You should never change the existing state. Instead, always override it by returning a brand new state object. And because objects and arrays are reference values in JavaScript, it's easy to accidentally override and change the existing state. You could, for example, think that you can do something like this, and then you return a new object where you then do set the counter to state.counter and show counter to state.showCounter. We can do this because we changed the counter here, and then we return a brand new object. Everything's good, right? Well, again, that will work. If I reload, it works, but it's still super bad because we still mutate the existing state, because objects and arrays are reference values in JavaScript. And in case it's not clear to you what I mean by that, attached you find a link which leads you to an article and a video where I explain this in depth. Now, when working with Redux and its state, you must never mutate state like this. Never change the original state which you're getting. This can lead to bugs, unpredictable behavior, and it can make debugging your application harder as well. So even though it doesn't lead to a bug here, it can have unwanted and unexpected side effects in bigger applications where your state gets out of sync and suddenly the UI is not reflecting your state correctly anymore. And hence the simple rule is never mutate your state like this. Always return a brand new object where you copy any nested objects or arrays, if you have any, and create brand new values, as we're doing it here. By updating our state like this, we create a brand new object where we don't change anything. And especially when you have a state with nested objects and arrays, it's easy to accidentally mutate your existing state. And therefore, you should be super careful that you do this in an immutable way, that you never accidentally mutate your existing state, but you copy any objects which you added. So you always create a brand new object or array whenever you need to update data. You never just dive into an existing object and start manipulating its properties. Always copy and create new objects. Now at this point, it might look a little bit too early to emphasize it like this, because this is a fairly simple state here, but it is super important, easy to mess up, and something you should know right from the start, which is why I am emphasizing it here. So by now we learned a lot about the important basics of Redux and how we use it. Now the more complex our projects become, the more complex it can get to use Redux correctly. Now the good thing is that in this course you will of course see many examples, also bigger projects than this one, but another good news is that there is a slightly easier way of using Redux as well. Now I wanted to show you the core foundation first, so that you understand how it works, but now I want to dive into an approach that's a bit easier to set up and maintain. Before we do that though, let's identify a couple of potential problems we could be facing here if our application would continue to grow. So if we manage more and more state with Redux. One potential issue can be our action types, these identifiers. I mentioned it before, you of course have to avoid typos. If you dispatch an action, you have to make sure that you don't mistype the identifier here, otherwise it of course won't be handled by the reducer or won't be handled correctly. Now that's not a problem in a small app like this, but in bigger applications, with a lot of developers working on the app and with a lot of different actions, it's super easy to imagine that you could mess up one of these identifiers. You could even have clashing identifiers there, so clashing identifier names. So therefore, having some way of defining those identifiers once and then reusing them would be nice. And that is something we can do with JavaScript and something I will come back to in a second. Another potential problem is the amount of data which we manage here. The more data we have, the more different pieces of state we have, the bigger our state objects get. And that means that we need to copy a lot of state. When we update the counter, we still need to copy and keep all the other state properties. And it also means that this reducer function gets longer and longer. And all of a sudden, we might have an unmaintainably big Redux file. And you might recall that I brought this up as one potential disadvantage of React context, if we put everything into one context provider file. Now we can end up with the same problem with Redux, but thankfully there are solutions for that with Redux. Another potential problem we could be facing is the state immutability, which we have to respect. I talked about it in the last lecture. We have to ensure that we always return a brand new state snapshot and that we don't accidentally change the existing state anywhere. And especially if you have more complex data with nested objects and arrays, it's easy to mess this up and accidentally change some nested data, even though you didn't want to. So it would be great if we would have some help with that as well. And if we could ensure that we don't accidentally manipulate nested data or anything like that. Now, for all those problems, there are solutions we could implement on our own. For example, for ensuring that we have unique identifiers and we don't mistype, we could create constants, let's say a constant named increment, which stores this identifier, and we then export this constant, and we check that constant's value here, and we then import and use that constant in the counter component, so that here we use the type increment, and we just import increment. So we import increment from going up store index. That is something we could do to fix this issue. And these are approaches which we typically used in the past with Redux. There also are solutions for splitting your reducer into multiple smaller reducers so that you don't get this large, super big file. And there also are solutions and third-party packages which allow you to automatically copy state and ensure that you don't accidentally edit it. But we actually don't need to dive into those various solutions anymore. Instead, there is another library called Redux Toolkit. And you can just Google for Redux Toolkit to find its official page. It's actually developed by the same person or the same team as React Redux and Redux itself. And Redux Toolkit simply is an extra package which makes working with Redux more convenient and easier. You don't have to use it. Unlike Redux and React Redux, which we installed before, you don't have to install and use Redux Toolkit. But if you use it, certain things will get easier. And therefore, in the next lecture, we're going to get started with Redux Toolkit.